Hello dear students, so now we would move ahead in this chapter number 2 of class 6 mathematics, that is playing with numbers. So here I have some new questions for you. Question number 1 is test the divisibility of the following by 6. Means you have to check whether these three given numbers are divisible by 6 or not without actually dividing. Okay, so how would you check? Listen, a number would be divisible by 6 if it is divisible by 2 and 3. Remember this. If a number is divisible by 2 and 3 both together, then that number would be divisible by 6 also. Are you getting this? Yeah. If a number is divisible by 2 as well as by 3, then that number would be divisible by 6 also. So let's check 7020 first. Okay, 7020. Is it divisible by 2? Yes, it is divisible by 2. Why? Because what is the last digit here? It is 0. Okay, so any number which ends with the digits such as 0, 2, 4, 6, 8, then that number would be divisible by 2. We have already discussed this. We have already discussed the divisibility by 2. So this number would be divisible by 2 because it ends with 0. So you write here the given number is divisible by 2. Why? Since it ends with 0. Getting it or not? Yeah. Now you have to check whether this number is divisible by 3 also. So for that you have to add all the digits here. Are you getting it? Yes. To check how to check the divisibility by 3, if the sum of all digits of a given number is divisible by 3, then that number would be divisible by 3. Are you getting this? Yes. So here 7 plus 0 plus 2 plus 0 equals to 9. 7 plus 2, 9, 0, 0, nothing is there. So answer is 9. I think 9 is divisible by 3. Yes or not? So 9 is divisible by 3. Then 9 is divisible by 3. Then you can say, yes, the given number is divisible by 3 also. So you write here, since 9 is divisible by 3, hence the given number is divisible by 3 also. So we have proved the given number is divisible by 2 also as well as by 3 also. So hence the given number would be divisible by 6 also. So you would write here, hence the given number is divisible by 6. Are you getting this? So this is how you would do second and third question also. Second question, you can just think here, it is not divisible by 2. Getting it or not? Because it ends with 3 here. So it is not divisible. Any number which ends with the digit 0, 2, 4, 6, 8, then that number would be divisible by 2. But this number is not divisible by 2. So if it is not divisible by 2, so it cannot be divisible by 6 also. So second number is not divisible by 6. What about the third number? It ends with 0. So it is divisible by 2. Now whether it is divisible by 3, that also you have to check, add all the digits here. If the sum is divisible by 3, then you would say yes, the number is divisible by 3. Hence the number is divisible by 6 also. Are you getting this? So second and third question you have to do on your own there. Are you getting this? Very good. Now we would do the next question. Now you have to check whether the given number is divisible by 4 or not. So for 4 we have a rule, and the rule is, if the number formed by the last two digits, remember this, if the number formed by the last two digits is divisible by 4, then the given number would be divisible by 4. Let me repeat again. If the number formed by the last two digits, these are the last two digits here. Okay, so if the number formed by the last two digits is divisible by 4, then the given number would be divisible by 4. So you check this, whether this first number is divisible by 4. 4, 7, 8, 6, 5, 3, 2. Yes, it is divisible by 4. Why? Because the last because the number formed by the last two digits, what is the number here? 32. So 32 is divisible by 4, I think. 4 8s are 32. So 32 is divisible by 4. Then you can say yes, the given number is completely divisible by 4. So you would write here 7 8 6 5 2 3 2 is divisible by 4. Why? Because since the number formed by the last two digits, what is the number? That is 32 is divisible by 4. Are you getting it or not? Yes. So if the number formed by the last two digits is divisible by 4, then the given number would be divisible by 4. Are you getting this? Yes. So what about the second one here? Whether this number is divisible by 4 or not? I think not, because the number formed by the last two digits is 31. So 31 is not divisible by 4. In the table of 4, there is no 31 there. Okay. So you would say the given number is not divisible by 4. Why? Because since the number formed by the last two digits, that is 31, is not divisible by 4. Similarly, the third one, again it is not divisible by 4. Why? Because the number formed by the last two digits is not divisible by 4. Hence, the given number is not divisible by 4. Second and third question you have to do on your own. Okay. How would you do the second question? It is not divisible, na? So you would write it 1020531 is not divisible by 4, since the number formed by the last two digits, that is, what is the number there? 31, is not divisible by 4. This is what you have to write there. Similarly, you would do the third one question also. Are you getting this? Okay, note it down. Then after you would be moving towards the next question. Now, this is the next question before you. Here you have to check, here you have to test the divisibility of the following by 8 here. Okay, means whether these three given numbers are divisible by 8 or not, that you have to check. So which numbers are divisible by 8? Without actually dividing, you have to solve this. Okay, so which numbers are divisible by 8? So let me tell you the rule there. So rule is, you can write it somewhere. All the rules I have told you, you should write this also. Okay, so the rule for 8 is, remember this, if the number formed by the last three digits, now in case of 4 there were two digits, so here three digits. Okay, so let me repeat again. The number, if the number formed by the last three digits here is divisible by 8, then the given number would be divisible by 8. Okay, what I have said, just let me repeat again. If the number formed by the last three digits is divisible by 8, then the given number would be divisible by 8. So in this case, what is the number here formed by the last three digits? That is 64. So you have to check whether this 364 is divisible by 8 or not. So let's check 364. Let's divide it by 8. So how many times it would go? 8 4 ja 32. How much is the remainder? This is 364, na? Yeah. So 8 4 ja 32. How much is the remainder? Remainder is 4. And what would come there? 4. So I think 44 is not divisible. How many times it would go? 8 5 ja 40. You have the remainder here. So now you would say the number formed by the last three digits is not divisible by 8. You have the remainder there. So you would say the number formed by the last three digits is not divisible by 8. So hence the given number is also not divisible by 8. Are you getting it or not? So let me write this. So you would write it like that. I am checking for this. 8364 is not divisible by 8. Why it is not divisible by 8? Because the number formed by the last three digits here is not divisible by 8. Yes? So you write there, since the number formed by last three digits, what is the number there? That is 364, is not divisible by 8. Okay, so this is how you would write the answer of the first question. Now similarly you have to do the second question also. So how would you do this? How would you do the second question here? So let me write this here also. If you have written this, let me do the second one. So now you have to check the whether this 7314 is divisible by 8 or not, that you have to check. So first what we have to do, we have to divide this last three digits, number formed by the last three digits, by 8. Okay, so let's, what is the number here formed by the last three digits? It is 314. So you would divide this 314 by 8. Okay, so how many times it would go? 8 3 are 24. Getting it or not? So how much would be the remainder here? Remainder is 7. So what would come here? 4. So it would be divisible 9 times. 8 9 is 72. So 2 is the remainder. Again we are getting the remainder here. So again you would write the given number, means 7314 is not divisible by 8, since the number formed by the last three digits, that is 314, is not divisible by 8. Will you write it? Yes. Okay, let me write it. You would write it 7314 is not divisible by 8. Why? Since the number formed by the last three digits is not divisible by 8. Had it been divisible by 8, then you would have written here 7314 is divisible by 8. But it is not divisible, so you would write it is not divisible by 8. Are you getting this? Yes. So similarly, you would do the third one also. So here also divide this 712 first. This way, 712 if you are dividing, how many times it will go? 8 8 ja 64, 7 is the remainder, 2 8 9 ja 72. So in this case it is divisible. Look here, it is divisible, yes or not? So you would write 36,712 is divisible by 8. Getting it or not? Since the number formed by the last three digits, that is 712, is divisible by 8. This is how you would write the answer of the third question. Okay, third one is divisible by 8. Getting it or not? First and second, these are not divisible by 8. Would you write this? Okay. Okay, now we would move towards the next question. Now this is the next question. Next question is test the divisibility of the following by 9. It is similar to the test how means we have tested the divisibility by 3. It is similar to that. So in 3 we have written if the sum of the digits of a number is divisible by 3, then that number is divisible by 3. So similarly you have to do this here also. If the sum of the digits is divisible by 9, then the given number would be divisible by 9. Very simple. Okay, let's do the first one. Okay, can you write? Okay, I think you are writing the rule also. So write the rule. If the sum of the digits of a given number is divisible by 9, then the given number is also divisible by 9. Getting this? Okay. Now let's check whether the first one is divisible by 9 or not. Okay. So what is the first one here? It is 187245. So first what we have to do? We have to add all the digits here. So it is 1 plus 8 plus 7 plus 2 plus 4 plus 5. Let's add this. How much you are getting? 8 plus 9. Sorry, 8 plus 1, 9, 9 plus 7, 16, 16 plus 2, 18, 18 plus 4, 22, 22 plus 5 would be 27. Look here. How much you are getting here? You are getting 27. And this 27 is divisible by 9. 9 3 is 27. Okay. So here the sum of the digits is divisible by 9. So hence the given number is divisible by 9. So you write there. Hence the given number is divisible by 9. Similarly, you would do the second question also. Here add all the digits. 3 plus 4 plus 7 plus 8. How much it is? 3 plus 4 7. 7 plus 7 14. 14 plus 8 would be 22. So 22 is not divisible by 9. So you would write 3 4 7 8 is not divisible by 9. Okay, because the sum of the digits is not divisible by 9. Similarly, you would do the third question also. Okay, are you getting this or not? Okay. So second and third you have to do on your own. And now in this question you have to test the divisibility of the following by 11 now. So whether these three numbers, given numbers, are divisible by 11 or not, you have to check this. So what is the rule there? So let me tell you the rule. Rule is, if the difference of sum of the numbers at even places and sum of the numbers at odd places is divisible by 11, then the number is also divisible by 11. What is that? Let me repeat again. If the difference of sum of the numbers at odd places means like first place, second place, third place, fourth place. So first and 3, these are the odd places. 2 and 4, these are the even places. Okay, are you getting this or not? Okay, this is the first place, this is the second place, this is the third place, this is the fourth place. So first is odd, this is the odd place. Third one is also odd. 2, this is even. 4, this is also even. So the condition is what? If the sum of the digits at odd places, sum of the digits at odd places and the sum of the digits at even places, if their difference is divisible by 11, then the given number is also divisible by 11. Okay, so let's do the first one. Okay, hope you would understand this after. Okay, so let me tell you the first question here first. So it is 5335. So first we have to find the sum of the digits at odd places. So first write there, sum of the digits at odd places. What are the digits at odd place? Which one is the odd place? First one odd place, second one even, third one odd, fourth one even. So what are the digits at odd places? 5 and 3. 5 and 3 are odd place, na? This is first one is odd, third one is also odd place. So these two are odd places. You have to add this. 3 plus 5 would be how much? 8. Okay. Now sum of the digits at even places. Sum of the digits at even places. What are the digits at even places? Here first even place, that is 3, second is 5. So here 5 plus 3. Again if you are adding, you are getting 8 again there. Okay. Now you have to subtract both these sum. Difference. So difference would be 8 minus 8. It is 0. So 0 is divisible by 11. Yes or not? Yes. If, remember, if the difference, whatever the difference you are getting, if the difference is divisible by 11, then the given number is also divisible by 11. 0 is divisible by 11. 11 0 is 0. Getting it or not? So you would write, hence the given number is divisible by 11. Are you getting this or not? Okay, so this is how you would do the first question. Now let's move towards the second question. Okay, note it down, then I'm going to erase this. Okay, now we would solve the second question here. Rest I am just writing as it is. Okay, now second question is it is 70169803. So let's find out the even and odd place. First one is odd place, second one even, third one odd, fourth one even, fifth one odd, sixth one even, seventh one odd, eighth one even. So we have just marked the even and odd places. So first we are to find out the sum of the digits at odd places. Which are the digits at odd places? 3, 8, 6 and 0. Okay, 3, 8, then 6, then 0. So 3, 8, 6, 0. 3, 8, 6, 0. These are the numbers at odd places. Okay, just add all these. 8 plus 3, 11. 11 plus 6, how much? 17. Now sum of the digits at even places. What are the digits at even places? First is 0 plus. Second one is 9 plus. Third one is 1 and 7. 1 and 7. So add these all. 9 plus 1, 10. And 10 plus 7, again 17. Find out the difference. Difference is 17 minus 17 is 0. So now if you see, this is coming 0. So 0 is divisible by 11 or not? So if the difference is divisible by 11, then the given number is also divisible by 11. Okay, so hence again here also, hence the given number is divisible by 11. Similar. Okay, note it down. If you have noted, Okay, let's do the third question now. Third question is what? Let me solve this here. It is 1 0 0 then 0 then double 0 then 1. Okay, first mark the even and odd places. First one is odd place, second one even, odd, 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 even. Okay, so now sum of the digits at odd places. What are the digits at odd places? 1 0 0 0. Okay, 1 0 0 0. 1 plus 0 plus 0 plus 0. Answer would be 1. Now sum of the digits at even places here 0 0 0 1. So 3 0 and 1. So answer is again 1. Subtract 1 minus 1, again 0. So since the difference is 0 and 0 is divisible by 11, getting or not? So again you would write hence the given number is also divisible by 11. So here all these three given numbers are divisible by 11. Are you getting it or not? Yes. So this is how we have tested the divisibility of the given numbers by the different numbers like 3, 6, 4, 8 and 11 and 9. Okay, so this is all for today. Would be discussing some new question in the lectures ahead. Till then, stay tuned and keep watching. Thank you. Have a good day.